We discussed about the Java class structure and visibility modifiers in the previous chapter. In this chapter, we will discuss about the core elements of a class and look at a standard representation. How do you represent a class pictorially, for which we use something called as UML, Unified Modeling Language. So we'll see how you can look at a class in UML notation, and also discuss some of the sample classes which we see in various domains. Let us explore the core elements of a class. So what are the core elements in general? So if you look at the core elements, so it's a huge list here. So first thing is some documentation. So every class will have an option to be documented. So we discussed about document comment earlier in the earlier chapters. So every class can have some kind of a documentation, and then we'll have an access type. So a class can be a public class or a private class as well. So typically most of the classes that we write will be a public class which can be accessed directly by a Java program or a JVM in general. For example, if you want to invoke a main method, it should be a public main method only, and it should be inside a public class. This is very much important in Java. However, we do have other access modifiers as we discussed in the previous chapter. We do have private, protected, or public. So typically the class name will be public, and then the class name would come into picture, which is, for example, here the name is rectangle, and it can also have an optional parent name. In our example here, we are saying extends shape. Rectangle is a shape. Do you agree? So is a relationship where we basically bring the parent-child relationship, and shape is a parent class which can also have its own attributes and methods, for example. And we do have extends, which is another keyword which is used in Java to provide a relationship to the parent object. And to be more specific, in Java, all classes extend java.lang.object. So that is another important element that we need to understand. And there is a super class for every class declared in Java. There is a super parent called as object. So this is every class is extending java.lang.object, which is by default. Okay. So a class name is required. So you can specify a name for a particular class, and then we do have the parent name, and then you have attributes. So what are the attributes? So we see here private int length, private int width. So I guess by now you are clear with what is int length, etc. So private is something which represents the modifier inside a class, because so far we've been declaring certain variables within the main method. That's it. We did not create a class and looked at from an object-oriented programming perspective, and this is the place where you would also get started with that concept as well. Then a class is constructed within a piece of code known as constructor. And that is what we see here. A constructor can also be a public or a private or a protected depending on our requirement. Most of the places we see public constructors, and public constructor can take certain parameters and then implement the logic which is required for initializing the variables or initializing the attributes of that particular class. So that is the basic intention of a constructor. Okay, so where it constructs that particular object, and one class can have multiple constructors also. It is very much possible. And then comes methods. So there are different methods. A method can be protected, it can be public, it can be private as well. This is something which is supported. Then finally, we do have a method called finalize, which is invoked when an object is destructed or when the memory is released. We'll talk about object destruction later, but this is the basic element. So there is no literal destructor method as such defined in Java or supported in Java, unlike languages like C++. So C++ has a concept of a destructor. So we don't have a destructor concept in Java. In Java, we do have something called as a finalize coming to picture, and this method invocation is not under the control of a developer. It is not under the control of a developer. So developer does not have direct access or will not be aware when it will be called. We'll talk about that in the later chapters. How does it work? So in order to provide a UML representation, so what is UML? I was talking about classes which can be related where you have a hierarchy. To represent this, we have a modeling language called Unified Modeling Language. So whenever you are designing a class, you can represent the attributes and the methods inside a rectangle and give a name of that particular class, something like an employee, and this is class name, as you see in this diagram, class name, and then we have different attributes, and this is access modifiers, plus is public, minus is private, hash is protected. So there are different notation which is basically being used, which is universally accepted, and it is a unified modeling language which is basically used for designing and representing the design of a particular class model in general. So in design classes, in the more advanced courses, we'll discuss about UML in detail. Okay. For now, it is just a know-how, nothing else. Because in some books or places, you might basically come across this representation. So be aware of it. That's it. Nothing to do with this modeling, etc. at this stage for you guys. Okay. Next, what are the sample classes that we can have? So you can have sample domain classes. For example, customer is a class in a domain like e-commerce, right? So if you are an Amazon, if you have an Amazon account and you are buying something on Amazon, for example, you are an end customer for Amazon. So you have the concept of a customer. Bank, we have a customer. Then we have student, we have an employee, we have doctor, product, reservation. If you are doing some booking, there is concept called as a reservation. So all these things are known as generally domain classes which are specific to a particular domain. For example, in healthcare or a hospital domain, we have classes like doctor, we have nurse, we have lab technician. So like that, there are different classes in hospital management domain. If you talk about a domain something like college or education domain, we have student, you have lecturer, you have department. So like that, there are different classes. What we see in our daily life, we model them in object-oriented programming and encapsulate that behaviors and attributes inside a class. So that is what is the essence of object-oriented programming. Then we do have Java classes which are core Java classes like string, system. We do have other classes types which we have not yet gone through, but we will see something like hash map, for example. Similarly, we can have certain classes provided by C++. So C++ has something called as an MFC, Microsoft Foundation classes. So Microsoft C++ has C string, C window, vector. These are some of the C++ classes. You have ASP.NET classes for visual representation, where we have button, grid view, page, etc. So these are some of the examples of different types of classes which are basically present in practice. So these are the elements of a class in general. So I hope you got an understanding of what are the elements, and in the next chapter we will walk through the life cycle of an object. So stay tuned.